Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up, everybody? Sunday fun day. Let me get this started on Discord. I need to update our events on Discord so everyone can see it. What's up, Zhangju? Jaden. Thanks, Odin. I already see a question from you too, by the way. That's awesome. Bum, 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 ba-da-dum, dum, dum. I ran a what was it? You have a physics exam tomorrow. All right, let's get you prepped for it, dude. I see something about like sound intensity. We're doing like decibels and stuff. Yeah, sorry, I ran a 5K race this morning at like 9 a.m. And so, 10 a.m., sorry. My lungs always get like kind of messed from it. It's like too much breathing. Okay, but cool. Yeah, let's pull up your question there. Because I got about 2 hours to help people today. And what's up, Justin? Where's y'all? Bum bum bum.
Yo.
What up, Justin? How's it going, dude? How's your Sunday?
Yo, what's good? It's good. It's good.
Was good. Was good. What are you playing? You playing the new Delulu?
Okay, I just been playing. What is it? OG.
Oh, Fortnite OG.
Yeah. And some like a tiny bit of like actual matches, but the Demon Rush mode.
The mode we played the other time.
Horde Rush mode. Yeah.
That was fun. I enjoyed when we played that one. I'm gonna get back into playing video games with you guys. I always say this, and then like, I forget that the whole point of this server, right, was for us to play video games together.
Yeah.
So I will start doing it again. Maybe we'll do like a tournament midweek or something. Maybe over the weekend. I don't know. I was busy building for this Burning Man thing all weekend, and then. But I said I'd still stream with you guys on Sunday, so we'll figure it out. Yeah. Good.
Yeah.
When are we gonna get Battlefield 6? Is that next week?
I think it might be in the next 2 weeks.
Oh, okay.
Either 2 weeks or a week.
Sick.
Right now,
Okay.
I'm Fortnite. Peak.
Nice. Here, let me do some questions with some kids. If you have any other questions, Justin, like, how's school going, dude? I mean, I know we love video games and stuff, but how's school going? School's good? Can't complain? School's good. Okay, cool. All right, let's start the stream. Help you guys with math and science, and here we go. Welcome everyone to Actual Education Office Hours. My name is Dr. Gold. This is a stream that helps you out with math homework, science homework.
Nice.
All sorts of fun stuff. First question of the day. So actually, let me go through the queue real quick. Well, let's see. And what's up, Jaden? Good to see you too. All right. And then here, let me make sure my chat's working in all these different modes. Select live sources. Shorts, good. Let's activate that. Let's activate this one. Just some ticky talk. And then don't stop the source. Activate the source, please. Sometimes I have to like sign in. Let's see if this works. I have to like go to my channel and click on my live. Can I see my live, please? Oh, all right. It says it's working. Okay, whatever. I trust it. Let's do a little test here real quick, just to make sure TikTok's working. Yes. Okay, cool. All right. First one coming up. Odin Root. This has to do with sound and intensity. It says the combined sound intensity of all fans during a soccer match was 113 decibels. Wow, that's loud. I think like hearing damage starts at like 100. So 113. That's insane. Assuming there were 99,000 fans present at the time, estimate the average sound intensity level in decibels for a single fan. Okay, cool. Well, let's talk about like what decibels is, right? I mean, you've probably seen it before, but here, let me get the equation for decibels. Yes, here we go. This is what I want. And they want the average sound intensity level in decibels as well. Oh, interesting. Okay. So yeah, dBs is a way to measure how loud things are, and it has to do with what's called sound intensity, I. And the classic way we measure decibels is relative to this thing called I naught, which I naught I think is like the lowest sound intensity that can be like heard by the human ears, like the softest noise you can like audibly detect is I naught here. So this is saying that in a soccer game, you had 113 decibels, which is equal to 10 times the log of some intensity over I0. And so we could figure out the intensity here, right? So the way to do that, divide both sides by 10. That's going to get me 11.3. And that's going to give me, not 11.13, sorry, 11.3. 11.3 is equal to log I over I naught. And then, since we're solving for I want to get intensity, and then I think I'm just going to divide that intensity by 99,000. I'm going to assume it's linear, right? I'm assuming that like the intensities add up. I hope they do. So I think what we do is we do 10 to the, in this case. That's how you get rid of logs, if you have some variable that you're trying to solve for. So 10 to the 11.3, which I need to pull up my calculator for that one then. Let me go find my shiny calculator. Can't have this normal boring one. Okay, cool. All right, so calculator. So 10 to the 11.3 That's a very, very big number, but okay, cool. So 1.995 times 10 to the 11 is equal to I over I0. Let's remember that I0 is 10 to the minus 12. So multiply this through by 10 to the minus 12. And so I total is going to equal to 10 to the minus 12 times 1.995 times 10 to the 11. Let's see what we get. So times 1 e to the minus 12. Going to get us 0.195. Okay. 0.1995. Which I should have seen, right? 10 to the minus 12 times 10 to the minus 11. That's just going to move the decimal place 1. Okay, cool. So that's the total intensity, which doesn't seem like a lot, right? This seems like kind of like a small number. But I think this is watts per meter squared is what this is. So it is actually like quite large. You have an easy question? Cool, submit it. Submit it to our, so we have like a pretty cool website that has a queue that you can do. Who were in Paris? I was not in Paris. Okay, so then I for an individual is going to equal this 0.1995 divided by 90,000, I think, right? You have a test for math, Jaden? Okay. You want to submit some questions for us to go through that can help you practice for it? I'm down. Okay, whatever. So then divide this by 99,000. So now this is 2.01. You sent in office hours? Okay, cool. Its intensity, yeah, right? This is logarithms. So this is the intensity of an individual person, but I think the question originally wants it in decibels for a single fan. They want it in decibels. It's interesting that they want sound intensity in decibels here again, but fine. Oh, okay. Oh, so we honestly should have just kept this in the log. Sorry, because now we're just going to go back and do the same thing. So then I'm going to do 10 log of whatever this is over 10 to the minus 12. Okay, fine. This is kind of silly. And so, yeah, log of that. Wait, it's divided by 10 to the minus 12, right? Yeah, okay. Log of that, it's going to give me this. And then we're times 10. Okay, cool. So then that gives me 63 decibels. Which, that doesn't sound too loud. But apparently I think that's what the answer is. Yeah. 63 decibels. Which here, if you ever want to like see like what decibels look like and different things. So decibels chart. This is kind of cool. Yeah, here we go. Know your noise. Here we go. Yeah. Okay, so decibels. So 50 is like moderate rainfall, apparently. The softest someone can hear is 0. Okay, that makes sense then, right? Because if your sound intensity, so if you have 10 log of I naught over I naught, that's 10 log of 1. Log of 1 is 0. So that's why 0 decibels. Yeah, so this is right. So I0 is the lowest intensity that a human can hear. So yeah, per person, 63 decibels is not very loud. It's like normal conversation. But if you have 99,000 people all having a normal conversation at once, where you submit, there's a website down there. It's actualdiscord.com. Yeah, just go to that website. Cool. Yeah, but combined, right? They said it was 111 decibels is what the sound intensity was. Yeah, 111 decibels is, yeah, nightclubs, sporting events. This is loud. So very loud. If you're exposed to this for over 30 minutes, it does cause like hearing damage. And then, yeah, 120, 130, 140, this stuff will like really fuck your ears up. Cool. All right, hope that makes some sense, Odin. Good question. Log of I is a thing. Log of 1 is. Yeah. So when I said log of I, Baz, I was referring to this question when we were looking at like what decibels is, which is a way of measuring how loud something is. You measure the log of I. This is the sound intensity of some noise, and it's divided by I naught. And what we're saying is that if the sound intensity of what you're listening to is I naught, then I naught over I naught is just 1. And the log of 1 is just 0. So that's why 0 dBs refers to the softest thing that you can hear as a human. Yeah. Yeah, it's not I like imaginary I. Cool. Okay, good question. Let's see, next one. So here, let me clear that from the queue. Where's our queue? Where's our queue? That was 4. Let's queue 4. Wait, I can definitely queue it from 4, right? There we go. Okay. Jaden, you sent this in office hours. Let me see what you got. Okay. Oh, the Cambridge IGCSE? IGCSE? Cool. Is there a specific question you want to work on? I mean, there's a bunch here. Maybe you can like tell me like which one's the hardest one you have to work on. I would say maybe the later ones are kind of difficult, right? Yeah, this is probably a good one right here. If anybody else has a question, please feel free to drop it in our website, and we'll get to it today. Okay. So Jaden, what about this one? Calculate the value of y. This is one of the later ones. This is a pretty good question. So you have two sides, an angle, and a missing angle, right? It's tempting to try to just use trig functions right off the bat. You know, like opposite of hypotenuse or adjacent of hypotenuse. The only issue is that you can't do that when you don't have a right triangle. This is not a right triangle. Because one of the angles is 105 degrees. So there are other rules we can use that involve sup nerds, involve trig functions, and the key one, there are two here, right? There's what we call the law of sines and law of cosines.
Not this one.
You don't want to do this one? Okay, because this...
Question number...
which one you want me to do?
Go up.
Oh, you want me to open it up on here? Yeah, fine, that's fine. Give me a second.
Let me check. This
All right, which one?
This one is...
17?
17, I'm not too sure, but did my teacher discuss already, but I'm not too sure. Can you explain?
Yeah, I can definitely do 17. That's fine. Yeah, so this comes from... This is another circle theorem is what this is. Yeah. Law of sines, right? Tio, that was the other one, yeah. This one you could solve pretty easily with law of sines. Let me just write the equation real quick for this one because other people in the chat were looking at it. This one would just be sine of y over 8.3 is equal to sine of 105 over 16.2. And then you just solve for sine.
So, cos rule also can, right? Cosine rule.
Yeah, so you can do the law of cosines if you have 3 sides and an angle. If you have 2 sides and 2 angles, you need to do the law of sines. So law of
3
sines.
sides and 3 angles.
Yeah, law of sines is 2 angles, 2 sides. Okay, and that includes like things you know and things you don't know. So for instance, I know 2 sides, I know an angle, and I'm missing an angle. So that's what I call it, like 2 sides and 2 angles. Law of cosines is when there are there's 1 angle involved and 3 sides. That's when you want to use the law of cosines. Thanks, Kyle. Appreciate it. Yeah. This one is law of sines, which is totally cool. Pretty basic one to do. Let's do this one. This is a circle theorem, which I think this one... Let me go find the circle theorem I want. It's this. It's one of these. Okay. Yeah. So notice how they give you an outside angle here, right, Jaden?
Yes.
And they say,
喐到冇而家，
喐到。
喐到咗啦。
oh, interesting. Oh, okay. They say this is a tangent line, right? Right, Jaden? They say that this line right here is tangent.
Yes.
Okay. So when you have a tangent line and then they give you this angle is the same as this angle. And that comes from this. It's called the alternate segment theorem. Okay. So when you have a tangent line and you have an angle formed on one of the chords, the angle opposite that chord is the same as this angle.
Just like sine cos tangent, the opposite angle.
Kind of. So, for instance, this is the angle, right? And this is the chord, right, that this angle makes with the tangent line. So I look for what angle is opposite of that chord. And that angle's here. It's angle A.
Okay.
Okay. I'm just gonna... I don't know if this helps us right away, but I think it does. And I'll show you why I think it does. So this right here, we know is then going to be equal to 53 degrees. Okay.
Yeah.
Okay. Now, if I know this is 53 degrees, do you see how that maybe helps me figure out what this angle is?
106.
Good.
My man.
All right, so this one is now 106.
So if
Okay,
I
cool.
90 minus 53, what if I 90 minus 53? Also can, right?
I don't know about 90 minus 53 yet. Just give me a second.
If I minus 53, I get here. The two angles. Isosceles is 180, so give me
Oh, I
106
see.
again.
I see. Yes, because this angle and this angle... So, sorry, this side and this side are isosceles then, right? Is what you're saying?
Yeah. Yes.
Yeah. One sec. I don't know how that helps you yet. Because, yeah, then I know that this angle is equal to this angle.
Yes.
OC is perpendicular to the tangent line. I agree. So this is 90, right? So I could figure out this angle, which then would tell me this angle. How's that going to help me get this angle, though? Sorry.
360 minus that. 360 minus the angle you found.
Oh, I think I see what's happening. Ahmed says the bigger angle is 254. And all the other ones add up to 360. Perfect. Yeah, that's a cool way to do it. Yeah, nice. Yeah. So I guess what we're saying, right, is that this right here then must be 106 degrees, right? That part of that, yeah. And then, cool. I think I see what's happening here. And then, so this part, right, has to be the same as this, yeah? Like this thing combined. Which, this, you know, needs to add up to 90. So, 93 minus 90 means this is 37 then, yeah? We agree with that?
Yeah.
In order for this to add up to 90. Okay, cool. So then this is 57. What's up, Equity? So if this is 57, then this angle must be 114, right? So this is 114 degrees, right?
Uh.
Like if we were to do this.
No.
No?
No.
No. Why no?
Wait, 90 minus... Wait, let me check calculator.
Yeah. So, no, if you go to actualdiscord.com, they're literally in Omar. Sorry, go to actualdiscord.com.
Right.
You can just drag your screenshot literally into here. Just drag your screenshot, put your name, and then just hit upload, and I'll see it.
Yeah, 90 minus 380. Wait. Wait, 180 minus 37 minus no, not 37.
Oh, you know what? No.
106.
I mean, this is even funnier, though. Yeah, no, you can as well. If you want to upload in the server, it's under help screenshots is the channel. But I'm just saying you don't even have to join the Discord if you don't want to. So okay, look, this is also a triangle though, right? Yeah. We agree with that.
I think I know how to do.
I think I know how to do it
I
too.
know how to do.
Yeah, no. How do you think, Jaden? I think because this is 37, this is 37, and then now we have a triangle.
No, because I use 360 minus that 106, then can get that angle.
360 minus 106 would get you this, right?
Will get me will get me the inside. Then 360 minus 53 minus 20 minus that, you get the answer 254.
Okay. But I don't think I don't think angle of X is 254. This
Yes,
is 30.
I
This
think
is
so.
no, it can't be. There's no way angle X here is 254.
Wait,
This
360
is
minus 106 first.
This is 37. Watch this.
360 minus
yeah.
106.
You don't need that. Watch this,
360.
Jaden.
Oh,
Watch.
254.
I know this is 53, right? I know this is 37. Okay. So if this is 37, then this is 37 because this is an isosceles triangle. Yes. I actually don't need this. I don't need this 106. Actually, we don't even need this. It was kind of cool. That's like one. Again, this is a circle with triangles, and there's a lot of ways to do this. I think this is the simplest way. Let's get rid of all this. I don't need any of this information here. You can only add one image at a time. Equity, yeah. What's my background? I have a PhD in physics. That's my background. Okay, so but watch this, Jaden. Jaden, watch. This is a triangle. What do triangles add up to?
180.
Good. All right, so watch. So now you have 53 plus 20 plus 37 plus 37 plus X has to be all equal to 180. Yeah, I agree, Renman, right?
Yeah.
Yeah, I think that's it. I think that's how we do this one.
180 minus 53 minus.
Yeah. So let's see what it is on the calculator, right? So that's 180. Ooh. Beast. Yeah, thanks, dude. 180 minus 53 minus 20 minus 37 minus. I think you have to minus 37 twice. Ren.
I think it's.
Yeah,
Right.
so I think it's 33 degrees. I think it's 33. X is equal to 33.
Wait, let me check ChatGPT for me.
You want me to check ChatGPT with this? Oh, fine. Whatever. Okay. Here, I'm gonna have ChatGPT try to solve this one while I work on another question because it'll take a while. It's right, bud. I appreciate that, Ahmed. Ahmed says it's right, so I believe it's right. Right? Ahmed said it's right. Okay. Okay, cool. All right. Good question. Let me make sure I get through all the other questions, Jaden, if that's okay, and then I can circle back and we can do more of yours. Is that cool?
Okay.
How about what you should do, Jaden, in the meantime, is go find another question that you want help with and find which number it is, and then that way you can just tell me right away what you need. Okay?
Sure.
Cool. All right, nice. Okay. Good job, everybody. Oh, thanks for the heart, Josh. Okay.
Well done!
Nice. Equity, I do see your submission. And then, Max, I do see yours as well. Let me do this one real quick. Just for Omar. And then Equity, you're next. I got you, dude. Oh, check the mark scheme. Oh, I think he's. I think he says there's. Oh, the answer's in the back here. I don't think I see them. No. Please help with my OChem. Oh, submit me a screenshot. I'll try and do it. Okay. Thank you. Oh, thanks for you. Thanks, Haji, dude. $1 Canadian. Sick. I'm gonna go buy some maple syrup. Okay, let's see. Batman leaves in pursuit of a getaway car 1 minute after the... Okay, so first of all, I don't like minutes. No. So I'm immediately going to convert this into, like, seconds. So here, let's just say 60 seconds. You can send it to the Discord, or you can send it on that website. actualdiscord.com/submit. There's a way to just drag and drop an image in right away. It's the easiest way for me to see the questions in the queue. Oh, okay, you get the marking scheme? Yeah. Well, let's see. ChatGPT, by the way, thought it was 33 degrees anyway, so I believe it. Cool. All right. The getaway car is traveling at a constant velocity of 126 kilometers per hour. Batman accelerates from rest. Okay, to 144 kilometers per hour in 8 seconds, and then remains at that velocity for the rest of the pursuit. What is Batman's acceleration? Great question. Okay. So, acceleration, or like average acceleration technically, is equal to change in velocity over change in time. Okay. So, he goes from rest to this speed. So, delta V is always V final minus V initial. And then change in time, that happens in 8 seconds. Now, the issue is I don't like kilometers per hour. Everything needs to be in meters per second in physics land. So we have to say how many meters per second is equal to 144 kilometers per hour. Use the website below. There's a way to submit. And then 1 hour is 60 minutes. And then 1 minute is 60 seconds. So this is called stoichiometry. This is very useful for converting units. And then 1 kilometer is 1,000 meters. So let me know, Omar, if this is confusing. I'm going to assume you know stoichiometry for units conversion. If you don't, it's okay. Just let me know. So let's get a number for that. You learned it? Cool. Well, did you learn it? Like, I'm sure the class learned it, but did you learn it? So 144 times, you just divided by, oh, I think that works actually. You know why that works? Because if you multiply by 1,000 and then you divide by 60 times 60, which is 3,600, yes, you're right. It's the same thing as dividing by 3.6. Wait, is it the same? Ooh, it is. Okay. And then, yeah, multiply by 144. Okay, cool. 40 meters per second. I mean, that kind of makes sense. Okay. Yeah, they call it the conversion bridge. That's pretty cool. Okay, so the nice thing is that it was it was a nice number. So this is 40 meters per second in 8 seconds. So that's going to equal to 5 meters per second squared. So there you go. That's acceleration. How long does it take for him to catch up to the robbers? This is great. Okay. So I want to write out 2 separate equations. I want to write out a position equation for Batman and a position equation for the robbers. Okay. So nice. Good job, Alex. So let's get their velocity in meters per second, because they have a 60-second head start. Okay, so x of the robbers, right? We're gonna say they get a 60-second head start, so that's gonna be 60 seconds times that 126 divided by 3.6. So what is it? 126 divided by 3.6. So 35. Okay, cool. So that's 35. So here's the equation I'm using. I'm using this one, which is x is equal to x naught plus v naught t plus 1/2 at squared. And for the robbers, great. I'm glad you're gonna learn. Come learn. The initial position is the 60-second head start they got plus times the speed that they were doing that 60 seconds of head starting at. Okay. And then we say that's going to be plus their initial velocity, which is the same as their final velocity. So that's going to be 35 times t. And then we say that the getaway car is traveling at a constant velocity. Constant velocity means acceleration is 0. So this is going to be plus 1/2 times 0 t squared. I do physics too, for sure. Okay, x of Batman. Batman. So Batman is going to start at a position 0. He's going to start at an initial velocity of 0, but he has acceleration. So that's 1/2 times his acceleration, which is 5 t squared. Now, what we want to do is we want to figure out when the position of the robbers is equal. This is kinematics 1 for sure. Is equal to the position of Batman. Yep. So to do that, I'm going to set this equation equal to this one. So that's 60 times 35, which I really should just get numbers for, but whatever. Plus 35t. This is the question right here. Yeah, it's right here. See if you can take a screenshot of that real quick, user. Yeah, acceleration at the top. Acceleration is the rate at which the speed is changing. So in physics, it's the change in velocity of the change in time. You didn't get that equation. Okay, this is a very... Omar, this is a very important equation that you need to know. I didn't combine anything, no. This is called the kinematics equations. You should know these in physics. Let me pull them up for you. I like this form. I don't like the I's and the F's. But whatever. Okay, that's fine. That's fine as well. Yeah, that's the same. That's the same as this equation. Yeah, it's just yeah. Okay, cool. That's totally cool. So what you probably used was this, which is the change in position. Okay, is equal to VIT plus 1/2 AT squared. And let me show you why it's the same. So change in position, remember, is equal to x final minus x initial. Okay, so change in position, which is this, is equal to VIT. Oh, you use delta D? That's fine. Delta distance is kind of... Distance is tricky. Distance is not the same as displacement, though. Or is it delta displacement they're using? I don't know. But watch what happens. If I move this over, Omar, x final is equal to x initial plus v initial t plus 1/2 AT squared. Oh, yeah. A block hanging on 2 ropes. Yeah, so, Mr. McGuire, if you find a screenshot of that question and submit it to our website, right here, this website, it's very easy. I will go through it. There's that's the best way. I have like a queue of questions to work through. Sorry, my fault. Let's go back. Okay. So what you have here, it's right there. The actualdiscord.com/submit. It's the link down below there. This is the same thing as this. Okay. So what I'm using here, this is the way I like to write it, but this can also be the way it's given to you. In any case, rather than just memorize equations, you should kind of understand what this means. So it's saying that the change in position, right, which your final position would be equal to your initial position plus the initial velocity times time plus 1/2 AT squared. Does that make sense, Omar? At least? Like how you can go from this to this? Cool. All right. So, I went to UCLA. So then this position of the robbers. So that's my equation of position for the robbers. He just didn't explain it. Yeah, typical. Well, if he didn't explain it, maybe have you guys thought about asking him to explain it? It might help. Okay. So this is the equation I get. And this is interesting because I have a t and I also have a t squared. When that happens and I also have another number, this means I'm going to have to use a quadratic. Oh, good. Thank you, Abdullah. Yeah, Abdullah actually brought up a really good point here. He remains at the constant velocity. Okay, good. Thanks, Abdullah. Yeah, no, I was wrong. Yeah, okay. It happens. Oh, that's annoying. Okay. All right, let's go. All right. How many questions are in the queue? It should say there. I don't think there's actually 6 though. Sorry. I can clear the first one and then I think the second one I can clear. Yeah. And then yeah. So there you go. There's three questions in the queue. It updates automatically. Yeah, I agree, Renman. Maybe that's the way we should do it. I don't really want to sketch things. Okay. Okay, scrap this. This doesn't work. Well, it doesn't work for the position of Batman is the issue. Okay. Yeah, because what this is the weird thing is his acceleration changes after a certain amount of time. Yeah, no, I agree, Abdullah. All right, so let's change this. Let's change this. I thought Batman kept accelerating. I guess he doesn't. How do you find love for these subjects? I don't know. I was just kind of good at them, so I want to help people. Let's do this. Let's find the position of the robbers and the position of Batman after 8 seconds. Okay, because that's when something else changes, okay? That's when Batman... stops accelerating. Yeah, let's just do that. Here's what we're going to do. So let's say, like, at t equals 8. Let's just get what the positions of them are, okay? So at t equals 8... X of the robbers... Because the robbers will already have their 60-second advantage, right? This will be 60 times 35 plus 35 times 8 plus this. This is gone. Okay. And then X of Batman will be equal to 1/2 times 5 times 8 squared. Okay. This is a tricky question, Omar. Like, and honestly, I got it wrong at the start anyways. Thank you, Abdullah, for showing me. What was my SAT score? I think a 1420. SAT doesn't really matter that much. My GPA is all over the place because of AP credits. Like, it's like a 6.0 system with AP. Okay. So the robbers are at 2380 meters, okay? And let's see where Batman is. What's up, dog? Mr. Worldwide News. You got any worldwide news for us today? Okay, and he's only at 160. Okay. All right, so this is at 8 seconds. And the other thing I need to know here, right, is how fast Batman is going. I have no clue what your SAT score is. So, V of Batman at 8 seconds is going to equal V naught, which was 0, plus A, which is 5, times T, which is 8. And so that's going to equal to 40 meters per second. Oh, dear. I'm so sorry. the taste of City Lounge suspect got caught. There's always some shooting happening at some point, right? Okay. So here. Now what we need to do is figure out what's happening after t equals 8 seconds. Okay. So now, X of the robbers is going to be equal to 2380. That's their starting position now. And then we're going to say plus V naught, which is their same velocity, which is 35, times T. Okay. X of Batman is now going to be equal to 160. They're running through time. Well, they're just really far ahead. But Batman is going to be going faster because now Batman is going at 40 meters per second times T. But he has no acceleration, right? Not after 8 seconds. The robbers never had any acceleration to begin with. Okay? Now what we do... So now this isn't a quadratic. I wanted it to be a quadratic. It would have been fun. So now we set this equal to this. Okay? So now 2380 plus 35t needs to equal 160 plus 40t. And this is a pretty decent thing to solve. Not too bad, right? So move that over, move that over. Yeah, we want to see when he catches him exactly, right? So this is going to be 2220. Is that right? Is equal to 5t. So then divide by 5. What's that? 444? I think T equals 444. All right, 2,220. Okay, cool. Nice. Okay. 1180. That's not bad. I mean, you could do better, but yeah. Okay, so interesting. So it takes 444 seconds, but wait, one sec. Key thing here. That's it. You have to also include the 8 seconds that Batman was accelerating. So really, T total is equal to 444 plus the 8, which is equal to 452 seconds. And then you just divide that by 60 to get minutes. So times, what is it, 1 minute over 60 seconds. So let's just do that. What's up, Meezen? Yo, what's up? Divided by 60. So that's 7.53 minutes. Do I do group theory? That's a little bit advanced for me. That's some pretty advanced math. We do have some other streamers on Twitch who are friends of ours that have PhDs in math, and they could probably do group theory. Right. Okay, cool. So this should be 7.53 minutes. Okay. Sure, Meezen. Yeah, submit it. So there's a new website now, Meezen, if you want to submit it. If you want to just submit the screenshot there, just so it gets added to the queue and I can see it. You can then send me other stuff, but just so I have a record of it. Okay, how far does Batman travel to catch the robbers? Oh, cool. Well, we know he had to travel at least 160 meters, right? And then I think you just plug that time, this time, the 444. Because that's the 444 seconds of him not accelerating. So, for this one, distance Batman. That's going to be the 40 times 444 plus the 160 he also traveled when he was accelerating. So 40 times 444 plus 160. That's a lot. We'll just say 1792 meters, which he probably wants kilometers, so 17.9 kilometers. So pretty far, honestly. There we go. Nice. That's correct. Sick. Awesome. Great. Love it. Does that make sense, Omar? Here, I'm gonna save this whole screenshot for you, and I'm gonna drop it here in chat for you. In the Discord. Let me see what Max, right? Name's Max in my Discord. There you go. Cool. Oh, also, yeah, you get a coin for asking a question. So, congrats. Am I a math teacher? Physics teacher technically, but I teach all sorts of things. I do math. What's the coin do? If you get 10 coins, I buy you a gift card, like $10 gift card to like Fortnite, PlayStation, whatever you want. So yeah, if you want to like earn prizes in our Discord for doing stuff like just getting help like this, feel free. I also tagged what the channel is. It's called like How to Get Prizes. Describe Lenz's law. Lenz's law is cool. Changing magnetic field creates currents, right? That oppose the direction of more magnetic field. Yeah, check it out. Yeah, check out How to Get Prizes and stuff. It's real. Everyone's always like, is this shit a scam? Okay, Equity, let me help you out. You're next. Okay, what is this question though? Is this more group? What math are you taking, dude? There's a website down below. actualdiscord.com/Schmidt. You can just drag and drop the screenshot into there if you want. No, I already have my PhD. I'm already done. I've done enough school. I'm 35. Justin, what's good, dude? So what's the question here? By the way, Equity, what is this? You wanna? Yeah, PhD in physics. Yeah. I'm really smart. No, I get really stupid on Saturday.
I might just mute the entire time.
You were muted. What's up the whole time? What's up, Frizz?
I was muted the whole time.
Oh, okay. That's all good. Yeah, send me another screenshot, Equity, if you want to go over this one, because is this gonna be like sets? Is the greatest integer not greater than all numbers? Like what's this question, dude? What's going on
Wait,
here,
are you
dude?
supposed to have numbers?
I feel like I need to have numbers. Okay, here we go. Okay. Okay, this is like set theory, which this starts to kind of punch the top end of what math I know. I don't know, I didn't really teach like set theory stuff. I think this is real analysis. I think it is. Which I might have to punt on this, Equity, because you might be getting too smart for me. You're starting to ask questions that like I haven't really studied this stuff. Oh, ChatGPT got this one right. Nice. Okay. Yeah, I might just throw this in the chat, honestly. Yeah, I'm throwing this question in ChatGPT because I don't really know set theory.
Damn.
But I will learn. I'll learn along. No, I'm totally honest in that I don't know everything. Yeah, like real analysis set theory, I never took a class on it.
Nobody
So,
knows everything.
yeah,
You'd be,
nobody
like, the
knows
most
everything.
Powerful human on Earth if you knew everything.
If I knew everything. I think my brain would explode if I knew everything. You know, there's a movie about that. It's called Johnny Mnemonic. It's starring Keanu Reeves. And yeah. He's like a robot. He's a robot, and like he has like 100 megabytes of data in his brain, and apparently that's like so much data that like his head explodes. Okay.
Damn. What the?
Yeah.
Still thinking.
And no, I think it got it. It got it here. Equity, I will try to explain this to you because I'm going to try to learn it with you, but I don't know if I can really teach this to you because set theory is a lot. What does a PhD do for you in physics? Like, what gateway and jobs does it open compared to a master? You can teach at the university level. So, like, I teach at UCLA. You can't teach at UCLA with a master's.
What is UCLA? I'm stupid.
UCLA. It's a university, dog. Okay.
UCLA.
UCLA. A relation on a set is an equivalence relation if it has any of the following properties. For any element A of set A reflexive A. I don't really know what that means. Okay. A reflexive B, then B R B. Oh, thank you. What's up, Jeff? Jeff, I knew I needed you here, dog. Come here, Jeff. Help me out. So, yeah. Theodore says the first is not an equivalence relationship, but the first is. What class? I taught 5A in the spring. I taught 1B over the summer. Physics. Oh, it's okay, Jeff. I miss you too. Oh, no, the other way. The second is an equivalence relationship, but the first is not. So, okay. And ChatGPT agrees with you, by the way. It says the first one is not. I do know Rate My Professor. I don't think I'm on there. I'm kind of a new professor, so I don't really have ratings. I mean, I have student rating. You guys ever want to like check out my LinkedIn and stuff? Totally can. Where is it? There you go. Have fun. If you have LinkedIn, I have some pretty decent like student reviews. Yeah, where's my student reviews? Yeah, here we go. You guys can go read what like the students say about me and stuff. I'll dump it in chat for you guys. Well, actually, you're in TikTok though. I don't know how to. I can't post links on TikTok. TikTok gets weird about it. All right. Let's see. 1.5 R1, but not 1 R1.5. So the first is not symmetric. For the second, here, Equid, I don't know if you can see this chat. That Theodore apparently knows this stuff. So maybe here I'm gonna like just leave it in chat so he can say. The answer key says it is not an equivalence relationship. For which one? For 13 or 14? For both. Okay, so equity is saying that both are not. The answer key can be wrong. 13 fails S and T. 14 fails all three. Okay. Theodore says 14 is. And ChatGPT says 14 is as well. So your teacher could be wrong. It does happen. Yeah. So Jeff also brings up a point that this is only on all integers, is what it is. So Theodore says x is the greatest integer, not greater than x. Equity's asking what's the difference. I love this. I love when my chat can answer questions for me. Floor of -4 is -4. Right, okay, yeah. Because the floor of -4.5 would be -5, right? Or no? Is that how floor works? Floor goes down to the lower number, right? Wait. Not floor of -4.5 is not equal to 4.5. I don't know if I can write it out because I don't really understand it. I don't. Yeah, I don't understand this stuff. I have a discrete quiz tomorrow. Yeah. Theodore says 1 is the greatest integer, not greater than 1.5, but 1.5 is not the greatest integer, less than 1. Yeah, exactly, Abdullah. I'm here with you. Yeah, this is like Chinese to me. So 13 fails the symmetry. And R is a relation. Okay. What the fuck is happening? Meeson says, yeah, we're trying to learn discrete math real quick here. Equity is surpassing the master in terms of math. Yeah, I don't know this stuff. I don't know, I can try to understand, I guess. All right. If B is an integer, reflexive. Does A equal A? Sure. Symmetric. If A equals B, B equals A. Transitive. A equals B and B equals C and A equals C. Well, for 13, it says all numbers. Yeah, but no, he's saying 13 is the greatest integer, not greater than all numbers. So, for instance, 4 is not greater than 4.5 for this one, right? But then, sorry, what's the reflexive thing then? But A is 4. Oh, okay. Okay, here. I think Theodore and Jeff have you on this one. I apologize. I can't help you on this. I don't know discrete, and nor do I have the time to learn it right now. So I'm gonna punt on this question. But feel free to keep chatting about it while I work on the next one. Let's see. This one was for more optics, dude. We're doing more optics for you, dude. Okay. During an investigation of a new type of optical fiber having index of refraction of 1.5, a laser beam is aimed at the flat end of a straight fiber, as shown in the figure. What is the sine of the maximum angle of incidence sine theta 1 if the beam is to not is... Wait, one sec. Laser beam aimed at the flat end of a straight fiber. Okay. My degree is in physics, correct, yeah. So I haven't taken any, like, yeah. The highest math I took was complex analysis. I never took any discrete. I never took set theory. Yeah. And I didn't do theoretical physics either. I did experimental. If I took theoretical physics, I probably would understand a little bit more about sets and groups and stuff, but I just don't. I'm an experimental physicist. If the beam is not to escape from the sides of the fiber if it is surrounded by air. Oh, so, right. N is equal to 1 here, but then N is equal to, like, something here. You can do that, Josh, if you want. It's easier if you submit it through the through the website. It's just easier to go through that way. Just so I have the queue. Thanks for the rose and the pumpkin. I don't know what those things do, but thank you, dude. Appreciate it. Okay.
That's what those gifts do.
Are they what? It's money?
Yeah, so you earn like coins and you can cash out those coins on TikToks.
Oh, sick. I can do shit with these coins, dude. Nice. This is where I have to go like, yummy, 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 yummy.
Oh, shut no.
You done messed up, Aaron! Oh no!
Oh no!
Okay, let's solve this one. Smell the roses, and I'll send 5 more. I don't know, like, you want some ASMR smelling on my mic? Is that me smelling the roses? You're gonna send 5 more for me? Oh man, looks like TikTok's making me. Yeah, critical angle. Sure. So critical angle, right? Which, let me look that up real quick. I gotta refresh my memory on this one. I think it's when you get like 1 over. It's when you get like 1 over 0 basically for this. Where's like a cool little diagram for it? Nice. Here we go. Yes, thank you. Oh wow, dude, he sent me 5 more, dude, for smelling the roses. Appreciate that. Thank you. But yeah, Theodore. No, I appreciate your input, Theodore. If you want to join my Discord and help Equity out, more than welcome to. That website has a link to our Discord, and then Equity is Bob Ross is in the chat. His name is Equity, and you can see his question also in like help screenshots. It's one of the channels in there. Okay, so right. So critical angle is the angle at which you get total internal reflection, right? Like it doesn't pierce through, because right, it just bounces off of it basically. It doesn't transmit through. And that occurs theta critical at is equal to sine -1 of N2 over N1. Where N1 is the material you're in and N2 is what you're piercing. So in this case, this is N. N1 is what we're in. Right? But let me see actually. How's this working? Sorry. But is it 1 over n? One sec. What is the sign of the maximum angle of incidence, sine 1, theta 1, if the beam is to not escape from the sides of the fiber surrounded by air? Wait, is this... This is so weird. I'm so confused. We need this to come inside here and then never escape. Oh, okay. Which is harder, like kinematics or dynamic? Dynamics probably. Kinematics is pretty easy. Dynamics is all the force stuff, right? Oh yeah, and friction. Yeah, I love that. Yeah, friction stuff's great. Okay, so let's talk about like inside the fiber, what you need, right? So, okay. This is going to come into here. And then whatever angle like this pierces at, right? I need the angle to be greater than the critical angle that it makes. I'm doing it right? Okay. I need to be greater than the critical angle it makes with like the boundary of the fiber, right? Okay. So let's figure out what the critical angle would be in order for some light bouncing inside of here to not transmit through. Okay. So in that case, this POV is better than the Discord cam. Really? Oh, that's cool. Okay, so in that case, N1 is N. Right? Because unless this equation is wrong, I think it's fine. And then this is, and then, oh, okay, and then this is 1. Aha, okay. Because here, this is, let's say, this is n equals 1 on the outside. This is the air. And then this is n equals n inside the fiber. Oh, it's sharp, nice. Oh, I should fix it then. Well, I think I need a more zoomed in camera for Discord. Okay, so let's get theta critical. So theta critical is going to be equal to arc sine of... And do they tell me what n is? Oh, they say 1.5. Okay, cool. So 1 over 1.5. Let's get that real quick. Sine of 1 over 1.5 is going to be 41.8 degrees. Cool. So that's the critical angle. It needs to be bigger than here. Okay. But now let's talk about the angle this needs to come in such that this critical angle is greater than 41.8. 41.8 is theta 1. Sorry, the angle. Yeah, sorry, the angle has to be less than. Sorry. Yeah. So theta must be less than 41.8 degrees. Right? Because theta is always measured from here. It's always measured from the angle of incidence. No, I think you're right. Yeah, so it has to be less than 41.8 degrees. Yeah. But then if this is 41.8 degrees, right, and then this is going to be 9, then we can put a restriction on what this needs to be. So then we can figure out what this is. So, this is going to end up being 90 minus that, right? So this is effectively like theta 2 in this situation that's happening, okay? Where we have N1. So watch this. So you have N1 sine theta 1 has to be equal to n2 sine theta 2, okay? In this case, n is equal to 1 on the outside. And we're going to say sine theta. And that's going to be equal to n2 here, which is 1.5. And then sine theta 2. But theta 2 is going to be 90 minus theta critical, right? Yeah? So let's figure out what that theta critical needs to be. Or sorry, let's figure out what this theta needs to be. Okay. This is physics. And then, okay, so that's sine of 41.8 degrees, right? So 90 minus 41.8. Oh, so isn't this cosine? Isn't this the same thing as cosine of theta critical? Oh, this is gonna fuck up, I think, actually. Watch. So, 90 minus 41.8 is gonna be 47.2. Let's see what that is. So, sine of 47.2 is gonna be that times 1.5. Uh-oh. So you get sine of theta is equal to 1.1. But this is impossible. Right? You can't have sine of theta can only go from -1 to 1. So, I think this means that all angles are okay then. Right? Because there's no way for you to reach the critical angle. Because think about it. Anything less than 41.8 is okay. Right? So, we could say, for instance, I don't know, like 10 degrees. For theta critical. Yeah. Wait, yeah. Theta critical is 41.8. Pre-calc progress bar is cool, dude. One sec. Let me think about this. Oh, okay, yeah. Yeah. Okay, I get this. Yeah, okay, because if you want total internal reflection... Sorry. Yeah, no, Abdullah. We want... sorry. We want theta to be greater than 41.8 degrees. Because we want total internal reflection, right? I need this angle to be greater than theta critical in order for it to keep bouncing inside the fiber. So, this has to be greater than 41.8. Yeah, not less than. Not less than. Yeah. So, we're already showing that at the boundary point, this is impossible. So, let's boost theta critical up to, like, let's say 60 degrees, okay? So then you have, for instance... 1.5 times the sine of 90 minus 60 degrees. That's the sine of 30 degrees. Sine of 30 degrees is 1/2. 1.5 of 1/2 is 0.75. Now it's okay. The diagram you're looking at and the diagram in the exercise are... No. This theta, right, is referring to the incident angle. Which here, when you have light coming in, this is theta 1, right? And then this is like theta 2. For total internal reflection, I need this to be the theta 2, okay? And anything that has a higher angle than the critical angle will continue to just bounce on the inside, right? It will not transmit. So that's for angles greater than theta critical. And so what we showed is that theta critical is 40, where was it? 41.8 degrees, okay? But if I want it to keep bouncing inside of that, I need to be greater than theta critical. Which means that 90 minus theta has to be greater than 41.8. Because 90 minus, that's the angle that the transmitting ray... Is the answer 67 to... Is it always 67? Yeah, no. Because, yeah, this is the angle at which it exits after coming incident on the outside of the optic. Yeah. No, I think this is right. Yeah, so I think this is... It doesn't matter. I think it works for all angles. What's up, Fembox? Fem, do you know anything about, like, group theory or, like, set theory? Equity was asking this question earlier on, like, equivalence relationships, and I couldn't answer it because it was, I don't know, it's outside of my, like, expertise. Okay. So, Odin, tell me if that makes sense. But I think any angle works. I can explain it again if it doesn't make sense. Maybe a little. Yeah, this was the answer I got from ChatGPT, and apparently his teacher's answer was that it failed. It failed on both. But ChatGPT seems to say that this one does not fail on all of them. Nice. Okay, cool. Awesome, Odin. Yeah, it's a cool question. Okay. Let me get the next one, which is Lewis.
Well done! Well done!
You'll think about it? Cool. Thanks, man. Meeson, yours did. You are, I think, third on the queue. So, yeah, there's a... Here, if we ever go to, like... This is what the queue is. So far. Oh, where'd that go? Sorry. There you go. This is the queue. So, Lewis, then Ren. Lewis has been waiting almost an hour. That's crazy. Thank you guys for waiting, by the way. Sorry. I got hung up on a little bit on some of the other questions. Yeah, nice. I don't think equities counts because that was just a repeat. So actually, let me remove this one on equities. There we go. Okay, now it's fixed. Cool. All right, let's do this one. It has to do with safe passage for a ship needs 9 meters of water at the shallowest point. 2 seconds earlier is crazy. Yeah, Ren just sneaking in there, dude. Yeah, it was close. It was literally 2 seconds. Thanks, Indian fans. Indians fans, cool. Are they technically Indians? Wait, what team is the Indians? Like the Cleveland Indians? Trying to remember if they're a team that got their name changed or something. Thanks, man. I appreciate it, though. Okay. For safe passage, needs 9 meters at the shallowest point of a tidal river in which the ship is traveling. The depth of the water at low tide is 6 meters, and the depth of the water at high tide is 11 meters. What is the earliest time in the afternoon at which the ship can pass this point safely, assuming that the water moves up and down in simple harmonic motion? Sweet. Okay, cool. The 1.5 million. Yeah, that's a different type of Indians. Okay. So, yeah, we need to build, build like a sine function, right? Yeah. So, all right. The low tide is 6 meters, so the minimum down here is gonna be 6. So let's draw that. Let me just like draw it graphically, and then I'll kind of like explain how we're gonna make an equation out of this. Okay, 6 meters is the low, and 11 meters is the high. Okay, this is cool. So this tells me, and then it's gonna do something like this, right? Oh, 1 second, let me refresh this. Wait a minute, 1 sec. Okay. Yeah, no. Yeah, no. The ship is not moving. I think it's just waiting. It's just waiting to travel. Okay. And we know it needs at least 9. Okay, so let's come up with... We want time 0 to be midnight. Okay. So time is equal to... And then they... Man, I don't like this format, though. Okay, I'm going to put T in hours. Okay, so we know at noon, so when T is equal to 12... so here's how we're going to write this. We can say, like, F of 12 needs to be equal to 6, and this is the minimum. Okay. So here, this is at 12. And then high tide is at 6:20. 6:20 is technically 6 hours after noon, so that's 18. And then the 20 minutes is 0.33 of an hour. So this is going to be at 18.3. 18.3 repeating. That's going to be equal to 11, and that's a max. So, yeah, let's put that up. But, sorry. How do I delete your question? You can't. It's there forever. You can tell me if you want me to skip it. That's okay. Okay. And so, we know it's got to be doing something like this, probably, right? This is not to scale. Don't kill me if it's not to scale. Yeah, it's supposed to be probably something like this, sorry. Okay, cool. So what's the earliest time in the afternoon in which the ship can pass this point safely? Yeah, Femvox, that is correct. That's what they came up with, but Equity says his teacher said that both of them were not an equivalence relationship. I am a teacher, yeah. I teach physics at UCLA. So we need to figure out where here that it's equal to 9. This is cool. That's a cool question. I like this one, actually. Okay. I wonder too, yeah. I don't understand. You'll probably have to do this for your major. What's your major, Indians fan? Oh, nice, cool. Well, tell her if she's taking physics, you know. I'm not teaching this quarter. I taught last quarter and over the summer. But I might teach again next year. That's why I'm streaming more this quarter, because I have more free time. Figure I'd help you guys out. Oh, okay. Let's call this this is a sine function. Yeah, let's define sine here. So let's say, okay, f of t is equal to, it's always the amplitude, right? What's the amplitude? Well, the amplitude is the halfway of the lowest to the highest, and the lowest to the highest is 6 to 11, which is 5. So the amplitude, right, is gonna be 2.5. So that's gonna be 2.5. And then this is going to be sine. We have to figure out what the period is. So we know from the min to the max is a difference of 6.33. So to go back down to the minimum would be another 6.33. So the period is equal to 12.66. Oh, atmospheric sciences. Cool. Nice. You could totally translate cosine 2 if you wanted to. Actually, sorry, that's what I meant to do. Sorry. No, you're totally right. Sorry, I meant to do cosine, because I wanted to start at the max. Yeah, sine would suck, actually. Let's not do that. Yeah, no, the period is from down to back up to back down. So this is 6.33, and then you need another 6.33 to get back down. That's period. No. Yeah, you're good, Jeff. Okay. So this is always, I think it's 2 pi over the period, right? Yeah. I think it's 2 pi over 12.66. Wow, what's up, Nerduino? Sunday Funday, baby. How's it going, dude? Let's give a big shout out. Nerd Raid. Yo, you came to the right place, dude. We're nerding out over sines and cosines right now. Shout out to Nerdwino. He's a G. What fun astronomy cosmos discussions were you guys having today? Let me know. My name's Dr. Gold. This is Actual Education. So we're a stream that we help out all sorts of middle school, high school, college level students with anything math or science. In terms of like, you know, homework, studying for tests. It's kind of like an open office hours for what would be a college situation where you'd go to a professor and be like, hey, I don't understand this. Oh, TKF. Oh, nice. You were their seminar guest. I just went on with, do you know Tiny Toxic Tofu? I just went on as her guest last week for, she's cool. She's another big science streamer. But I went on her stream.
Who's ready for a deal?
Oh, does she have it? Did she post it?
Oh,
I don't like these ads. Jesus, stop.
Right,
Oh, it was a great chat. Nice. Yeah, no, she's awesome too. Yeah, I had. Oh, this was it. This was the interview with a plasma physicist. Yeah, I need to get rid of my ads at some point. But yeah, I was on hers last Friday talking about plasma physics and education. Cool. I should talk to TKF about maybe giving a seminar for them as well. I don't know. Sage is always cool. Rocket Sage. Yeah, Ren's like, yeah, I have a lot of people on YouTube watching too. So yeah, for those on YouTube and TikTok, we stream primarily on Twitch. I do YouTube and TikTok as well, just to get more exposure to people who need help. But there's a really fun community on Twitch. I totally encourage you to go to that website, actualdiscord.com/submit, and you'll be able to see a way to watch us on Twitch. And then on Twitch here, you can find all our awesome, fun friends and partners that we also stream with. For those of you watching, yeah, if you have a math or science question you want to ask, the website, I'm gonna drop in the chat right there. Go to that website. You can enter your username, whatever. I don't care. Something that I know how to call you, and then you can drag and drop a screenshot of one of your homework questions, and we'll do it live here on the stream. So we're doing this one, which is kind of related to something in space. It's related to the tides, which are controlled by the moon, right? It's the gravitational pull of the moon, which causes water to go up and down in different parts. So, yeah, this was the period. This is going to be times t. And then we need to, I believe, put a phase shift on it, right? And so the phase shift is cosine usually would want to start at 0. But it's starting at 18.33, so you have to put minus 18.33. There we go. And then we need the midpoint for this thing. So the midpoint between 6 and 11 is going to be 8.5. Yeah. Nice. Did I screw up again, Jeff? Jeff's like, hold up, dude. Yes, I think you're right. Is it this? Let's think about that. Yes. No, you're right. It is that. Why not plus 10? Yeah, good. Because when t is equal to 18.33, the inside parentheses must be 0. I agree. Yeah, that's true. That's true. I agree with that. Yes. Yeah, okay. Why not plus 10? So the plus always refers to what's called like the midline for like any sort of harmonic motion here. And since you're starting at a low of 6 and a high of 11, the midpoint between that is 6 plus 11 divided by 2. And so that's 17 divided by 2, which is 8.5. Yeah. Okay, cool. So now we've come up with our equation for the tides. Yeah, you're good? Okay, nice. So now we need to set that equal to 9 meters. Right? So, okay. We're going to set this all equal to 9. We're going to say, okay, cool. 9 is equal to this. And now this is just algebra. The hardest part of this, the pre-calc hard part of this, was coming up with this equation from this situation. Move this over. You're going to get 0.5 is equal to all this. How's this going to help you get girls? I mean, if you do well in math and science, you're probably do well in other subjects and other aspects of life, which will then probably net you a pretty nice paying job. And let me tell you something from experience. Dating girls is expensive. It doesn't have to be expensive, but it certainly helps if you have money. So this will help you get girls because it'll help you get a job that has money so that you can go take girls out to nice things. And there you go. That's how it'll help you get girls. Being good at math will ensure they are the right kind of girls. Nerduino is so right. Yes. I agree, Nerduino. Yeah, that's totally a correct statement. Yeah. Yeah, you don't want the wrong type of girls, and you need to know how to do math in order to sort out which ones are wrong. Okay, so let's how's my calculator working? Okay, 0.5. Oh, there we go. 0.5 divided by 2.5. Just gonna be 0.2. Can I get girls with PEMDAS? Not directly. No. I mean, maybe you can impress upon them. Here's a statement for you, Mojo Jojo. Let's say some girl in your class doesn't understand PEMDAS, and you could teach her PEMDAS. That would demonstrate value, and that could be something that is seen as an attractive quality in you that, you know, could lead to you maybe getting a date. But then again, nobody in your generation goes on dates anyways, apparently. I mean, that's what I see in all the news. Everyone's like too scared or something. I'm like, okay. Okay, so in order to get rid of the cosine here, you have to do what's called arc cosine. So I'm going to arc cosine both sides. So if we do arc cosine of 0.2, and then let me remember if I think I need to do this in radians. Yeah, I'm pretty sure I need to do this in radians because we used 2 pi and stuff, right? If you had used 360 here instead of doing 2 pi over the period for omega, then you would do this in degree mode, but this is in radians. I know it's annoying to keep switching back. I know, I get it. I feel like this is a scam. What's the scam here, Raven? Is it 1 times 10 to the minus 12 or 10 times 10 to the minus 12? Wait, where's that from? 10 to the minus 12. Where's the 10 to the minus 12 from? Math equals getting girls. It's the butterfly effect. It eventually works out. Everything you do contributes to your trajectory in life. So try to do the right things. And then nice things will happen to you. Lies, all lies. Jeff is very pessimistic sometimes. Okay, here, I'm gonna just get the rest of this 1 sec. Let me put the calculator away because it's kind of annoying. Have you had careers outside of teaching? Yes. I've worked for a lot of startups in the past, in various capacities. I've done social media marketing for different companies. I've worked in e-commerce. I DJ. I used to throw a lot of desert raves during the pandemic. Those are fun. Not very profitable, but it was kind of a career. What's the highest level of math you can teach? Probably real analysis. Cool. All right, and then we divide this by 2 pi. Okay, I'm just skipping all the calculator steps to get you guys. All right, cool. So we get t is equal to 3.35. Oh, interesting. Mm-hmm. Oh, limit definition and real analysis? Cool. Okay, so we get t equals 3.35. So this is interesting. This is the primary time that this works at. Can you do second derivative test example for pre-calc? If you send me a screenshot of it, I'll do it. Send me a screenshot using that website down below. Send me a screenshot so I know what to do. Okay, so when t is equal to 3.35, is that the primary one though, Jeff? Like, what's going on here? I feel like something's wrong here. 1 sec. Let me make sure I did all this right. Draw the period before that one. I know I can probably just add period, but I want to make sure that's right. So let's make sure we did all this correctly. So we had 9. There's another one before that too. Yeah, I bet there is. Minus that was 0.5. That good. Yeah. Oh, dude, why is my calculator not working? Excuse me, calculator. The buttons don't want to work today. One sec. Oh, okay, there we go. Okay, I will check it. One sec. 0.5 is that. Oh, we should have divided that by. No, we're good. We're good. That. Okay, cool. Cosine of x is cosine of negative x, yeah. One sec. 12.66. Yeah. Times 12.66 divided by 2 pi plus 18.33. And then we divide it by 2 pi. Okay. Yeah, okay. So this value works, but then also you have to then do plus oh, I see. And the negative values. Yeah. Okay. Yeah, actually, you know the best way to do this? Let's just graph this. Yeah, this is the issue with doing arc cosine, is that you have like what's called like the ambiguous case, which happens in the law of cosines. And the reason why that is because when you take arc cosine of something, it can only give you answers in these two quadrants for arc cosine. So.
Hello.
What's up, Ethan? How's it going?
I'm doing alright.
Good.
You know, I'm in my midterm. I'm in
Nice.
my midterm right now. No.
Oh, Jeff, I think I see what happens. The issue is that if I wanted to get, if I wanted to, for instance, Jeff, if I wanted to get this angle right here using arc cosine, I wouldn't get it. I would end up getting this one here. Uh-huh. I see. Okay. All right. You know what I want? I think I just want to graph this real quick. I'm just going to graph it. It's easier to graph it. Yeah. Yeah. All right. Okay. 2.5. 2.5 cosine of 2 pi divided by 12.66 times x minus 18.3. Good. And then let's add that to 8.5. Let's trace this. And then we got to set our window. So there's our wave. We see our wave, right? And then here, let's set our window. The minimum we're going to say is 0. The maximum is going to be 24 hours, right? The Y minimum we know is around 6, so I'm going to set my Y min at 5. My Y max is at 11, so I'm going to set that around like 12. So now we can see it. Yeah, there we go. Cool. So this is the wave, right? So, and then what I want to do is also see when this wave is equal to 9. So we're going to put 9 in there. All right, now we can see where the intersection points are. So the one we got, the first one, right, that's way back here at like 13. All right, where did my calculator go? Sorry. Yeah. See here? This is the original 3.35 I think we got. Yeah. Well, something's wrong with that. Let me make sure it's right. 12.66 Yeah, x minus 18.33 plus 8.5. So we need times in the afternoon, which means we need times after 12. So that has to happen. And then look, make sure that there's a minimum at 12. Looks like there is, right? That's the minimum at 12. And then we can also check to make sure that there's a maximum at 11. And that happens at 18.33. Yes. Okay, cool. So that one works too. So this is the time we're looking for. The 15.57. So here you can just get the intersection of these two if you want. First curve, second curve, guess. There you go. Intersection should be 15.57. Okay. Which is basically this plus a period. Okay. Now, in order to convert that into hours and minutes, right? So this is the 15th hour and 0.57 of an hour. So we need to multiply this times 60 to get minutes. So let's do 0.57 times 60, and that's going to get us 34.2. So your final answer is 15:34 is the time. There we go. Cool. All right, nice. Great question there. Appreciate that one. It was fun. And 12 seconds, yeah, but they wanted the time in just... They wanted it in this format. They wanted it in 24-hour format, which is just hours and, like, minutes. Appreciate it. Yeah, cool. No, you're very welcome, dude. I hope that made sense. Honestly, yeah, you have to wait until the next minute to be safe. True. Okay. Good question. That was from Lewis. So let's mark that as done. Ren has a question about blocks and forces. This is cool. Okay. Consider the following 5 blocks, all resting on a smooth horizontal table. Suppose that there's a force F applied to the leftmost block. All the blocks remain in contact during the application of the force and accelerate similarly. Mark on all the forces on the middle block. Oh, sorry, on this one. What is the resultant force? More physics, your favorite.
Good job.
Yeah, okay. So, yeah, if you want to think about... Here, let me show you how this works. How do I... Jeff does not like physics. He's like, get this physics out of here, dude. We just did a math question, though, Jeff. Be happy. This one is cool. So, here's a cool thing in physics. I can treat this whole thing as a block of mass 5m. Okay, so we could say that I have a big mass 5m that also has a force F being acted on it. Right? And in this case, right, sum of force is equal to mass times acceleration. So F is equal to 5m times A. Right? So A is equal to F over 5m. Yeah? Now, that acceleration of the whole 5 mass system needs to also be the same acceleration of each individual block, because they're all moving together at the same acceleration. So I could say for the middle block, let's just look at the middle block, for instance. Let's just check this one out, right? This has to have an acceleration which is equal to F over 5m. And so the sum of the forces, so the net force acting on this block, has to be equal to its mass, which is just m, times the acceleration of that block, which is F over 5m. This is what we like, right? Yeah. So this is F over 5, correct? Yes. So the resultant force on the middle block is F over 5. Yeah. So you can say F net on the middle is equal to F over 5. Correct. Mark all the forces on the middle block. Okay. So on the middle block, let's say this is the middle. I mean, you obviously have the force of gravity pointing down. That's an easy one. Yeah, cool. No. Yeah, this is a great way to explain it. Yeah, no, I agree, Ren. Yeah. I like to do the trick of like just consider everything's like a big mass. And then you have normal force pushing up, and then here's the interesting thing. So this middle block here does not feel the force F directly. This is a mistake a lot of students make. They say that this must be feeling force F. It actually doesn't. Yes, we're gonna also assume no friction. Really what happens, if we label this as 1, 2, I don't know, like 4, 5, like, and let's call this like block 3, which is the middle block. This is gonna feel a force from block 2 pushing on it to the right. So this I would say is like F2 on 3, or sometimes your teacher will just write this as F2, 3. Now, as this middle block is getting pushed to the right by block 2, it's running into block 4. And so block 4 is going to impede its movement. So block 4 is going to push back on it. And so it ends up happening that it feels a backwards force here, which is called F4 on 3, which is also, they call this like F4, 3. Okay? And so this is technically all of the forces acting on it. If you wanted to solve for like each individual force here, it's a little tricky, I guess. Well, no, you can do it on this one, for instance. Let's look at the first block, right? So from the first block, and we're just going to talk about the translational forces horizontally. This has F pointing to the right, and then it has the force of block 2 pushing back on it. So we would say F2, 1, force of block 2 on 1 pushing it to the left. And the sum of these forces, which is equal to F minus F2, 1, that needs to equal to F over 5. Okay? So right off the bat, this tells you that F2, 1 is equal to F minus F over 5. Right? Now if we look at the second block, you have to kind of like go in a row here. Let's look at the second block. The second block experiences F1 on 2, and then it experiences the force of block 3 pushing back on it, F3 on 2. Now, F1 on 2, so the force that this block feels from block 1 is the same as the force block 2 felt from block 1. The same that the first block felt from block 2. So, yeah, let me tongue twister. One sec. Okay. Block 1 felt block 2 pushing back on it. Block 2 feels block 1 pushing back on it. And this is called a force pair. This is the equal and opposite force part of like Newton's laws. So whatever force block 2 feels from block 1 is the same force that block 1 feels from block 2. So this thing we solved for, F2 on 1, is the same thing as F1 on 2. And so now from our sum of forces, right, I'm going to say, okay, well, F12 minus F32 must equal F over 5. And so that's going to be F minus F over 5 minus F32 is equal to F over 5. So now F32 is equal to F minus 2F over 5. Sorry, not F over F, F over 5. Okay? And then that we can then use for here for F2 on 3. So this tells me, oh, cool. Well, F2 on 3 must equal the same as F3 on 2. So that's F minus 2F over 5. So now we can figure out F4 on 3. Because F2, 3... Let me do it in the green, sorry. Yeah, it's pretty cool, right? Yeah, this is dope, Ren, right? Yeah. So F2, 3 minus F4, 3 is now equal to F minus 2F over 5 minus F4, 3. And that still must equal F over 5, right? So now you end up getting that F4, 3 is going to equal F minus 3F over 5. You should start seeing a pattern here, right? Yeah, I want to keep seeing the force pairs and stuff, yeah. So eventually, right, when we get to like the 5th block, the 5th block is only going to feel block F4 on 5. And that's going to be equal. So if F4-3 is F minus 3F5, you could think that F5-4, just from symmetry here, is going to be F minus 4F over 5. Personally, I'm just drawing a free body diagram, calling it a day. I agree. But this is cool, because eventually you find out that F5-4 is equal to, look at this, F over 5. And that makes sense, because on the last block only feels block 4 pushing on it. And that force is equal to F over 5, which is exactly what it should have been. So yeah, if they end up asking you what all the individual forces are and like what the values of them are, this is how you can like technically do it. Cool. Good question. I like that one. Yeah. Free body diagrams are great. I think the most important thing to learn there in mechanics is that you need to be very careful and only think about what force is acting on the object when you draw a free body diagram, not what force that object is exerting on something else. Again, the common mistake that students make with this type of question is they'll see this F here and think it translates to here, and that this thing must be feeling F as well. And it doesn't. Yo, what's up, Don? Yo, shout out to Don, dude. Belated. Oh, hi, what's up, Snowart? Casey Snowart, you're awesome too. Yeah, Don Factorial. Good to see you this fine Sunday. Are you streaming today, Don? Yeah, the other one that comes up a lot is this, when you have like the 2 blocks on top of each other, and you end up like pulling one of these blocks this way, and like there's friction and you don't know like what's happening because like this is on the ground as well. This interaction gets very confusing sometimes. You're working on homework. Oh yeah, Dawn's in grad school. Congrats, Dawn, on embarking on the great journey, which is more education. I say stay in college forever, dude. That's why I spent so long on my PhD. I was like, I kind of like this. Let's just like keep staying in school. But yeah, the cool thing here is like, for instance, on block 1, you get like force of gravity. And then you also get some normal force, which you call like F2 on 1. That's for this block. But then on the green block, okay, that translates into, there's also going to be like the force gravity of the second block. Sorry, this is like FG1. But you additionally have what's called like F1 on 2. And this is like kind of the effect of this one. And of course, these two forces have to be equal and opposite. So this ends up being basically the FG1 from the first block as well. But sometimes if you're pulling on stuff at different angles, F21 changes because it's like the normal force. Yeah. Okay. Let's go on. Let me see where the Q's at so far. Where's it? Where's that? Okay. So that was Renren's question. So let's mark Renren's as done. Nice. Okay. Renren's done. Mizan and then Jebediah. I will try to get to yours, Jebediah. Mizan, I will spend a decent amount of time of yours, and then if I have to run to just quickly do Jebediah's, I will try. Oh, awesome. Don says, yeah, it was cool to see you on Tofu stream. Yeah, the plasma physics talk. Yeah, I still got it. I still remember enough of my plasma physics background to speak a little bit about it. Yeah, it's cool. She reached out to me and just asked to like interview. I thought it was cool. She's pretty big. She's a pretty big streamer. I think she's got like 12K on Twitch. And then she's got 80K on Instagram. She does really well on Instagram. Okay, cool. Let's see. A single force P... Oh, this is a statics question. Oh, no. Ooh,
What
no.
the fuck is this piece of shit?
It's gonna hurt. This one's gonna hurt. Becky, the stream is gonna end pretty soon. I do have to go in 15 minutes to go teach another student Algebra 2. But for those that are watching, yeah, if you ever want to figure out when we stream, again, if you go to the website link and you click on the streaming schedule here, you can see all the times that we stream, as well all the times that our other friends stream. Thanks for the follow, by the way, St. Everest. So we're on. Well, where's my calendar? Okay, this is us. Oh, so I'm on a little bit past schedule. But tomorrow, Zach is going to be on at 11 a.m. doing like some cool software development stuff. And then I'll be streaming again at the same time, 3 to 5. And I like this. Zach's opened up another stream on Tuesdays. He's going to talk about math. He's a math PhD. So if you want to ask some really high-level math questions, please go to his stream on Tuesday morning. And then I still have all the other stuff happening. What is this? Intersections with Math podcast. Oh, that's our podcast. Okay, great. I need to move this then. One second. I will move that eventually. I forgot what date we're doing it. It's okay. The recording's up. Yeah, if you ever want to go to Tiny Toxic Tofu is her name, but yeah. Perfect. Yeah. Yeah. There's the schedule. Yeah. Well, that's 3 to 5 my time zone, which is Los Angeles. Oh, that's cool. Well, welcome to the stream. La Palabruja. Oh, so you're a word wizard or a word witch? Isn't bruja like witch in Spanish? And palabra is word. Yeah. Okay, let me try to answer this for you, Mizan. A single force P. Oh Jesus. Acts in a direction perpendicular to the handle BC at the crank shown below. Determine the moment mx. Okay, so if this is the x-axis here, Mizan, right? This is the x-axis, right? Of p about the x-axis when theta equals 65. When theta equals 60. Okay, when this equals 65 degrees. Knowing that my is minus 15 and mz is that. Ugh. Oh, moments. For this question, we ignore reaction forces. Oh, Christ. Okay. So, yeah, this is where... engineering. Bless you, engineering. What is a moment? Is moment R cross F? What's a moment in engineering? Gold is having a moment. Yeah. Yeah. Okay. I need to know, like, just, like, engineering speak is what this is. It is R cross F. Okay, cool. That's what they... So it's just torque. Why don't they just call it torque? Do we have to account for gravity? Because technically there's gravity on this. But I don't know the mass of this handle. No gravity, no mass. Thank you. It's an ideal crank. Okay, cool. Alright, so let's write out the vectors for this. So the force is pointing in the theta direction, right? And that's going to be, sorry, in the phi, what is this? This is going to be in the YZ plane. So it's 0 in the x-axis, right? And then this is going to be, minus, and then, minus p sine sine phi. And then this is going to be, but positive z. I'm going to say plus p cosine phi. Right? We agree with that so far? And then I need to know r. Yeah. Interesting. Okay. Okay, so R is like where we're pointing to, right? Okay. Let's think. Let's think here, guys. I know in the x-axis, I have to go 250 millimeters, right? So that's going to be 0.25 for sure, right? X. Yeah, that's not going to change, I don't think, based on theta. Y will, though, right? So Y is going to go 200 sine theta, right? Yeah. Because if we look at this from the side view, and then this is like theta, then I need this amount, which is going to be 200 sine theta. Okay. And then the z-axis should just be 200 sorry, 200 cosine theta, no? Yeah. Is this what you got for your stuff? So then do I just do R cross F? Is that really all I do? I feel like I do. This is going to create like a big systems of equations, I guess, right? IJK. 0.25. Oh, and they told us theta is 65. Whatever, I'm going to leave it because I just don't want numbers. Meeson is talking. I took that approach and I hit a wall. Okay. I hope we're not gonna hit a wall here. I mean, I see two unknowns, right? I don't know P and I don't know Phi, and this should be solvable because I'll get more than 2 equations from this, right? I hate geometry. I'm never gonna finish. No, don't give up. Don't give up. You have so much to live for. Okay, so cross products, right? We do this. So this will be in the x component. It's going to be 200. So mx is equal to 200 sine 65 degrees times p cosine phi plus 200 cosine 65 degrees p sine phi. Okay, and this is what we're looking for eventually, right? But I do know what my is. Okay. So I know my, which is equal to 0.25 p cosine phi. That must be equal to negative 15. No, this is statics, Popoli. This is statics. Okay. And then mz, which is this one, must be equal to 0.25 or minus 0.25. It's icky phys. No, it's kind of math, dude. Yeah, she's like, it's math that's been made unclean by physics. Is negative 36. Okay, cool. Well, I mean, yeah, if you just use the definitions of moments. Well, once you guys told me moments is torque, I'm like, cool, I can do that. Yeah, so what's hard about this, right? This is nice. 2 equations, 2 unknowns. I can divide. So mz over my is equal to 36 over 15, which is just going to be equal to this divided by this. So that's going to be negative sine over cosine, so negative tangent phi, no? So tan phi is equal to negative 36 over 15. I don't know. Unless I'm like totally bonkers here thinking about this. I just you gotta like trust the force, Luke. You just gotta be like, I know what the definition is, and I'm just gonna do it. Oh, it's negative 36. No. Is it a 5, 12, 13 triangle? Is it? Okay. That's in radians. Whatever. I'll keep it in radians. What do they want eventually? So they just want mx eventually. Okay. Whatever. The average is 23. We'll see if we get it. Okay, I got my phi, right? So now I can just solve for p, right? With any one of these equations. We can solve for this one if we want. Are you a good person? I'm a gold person. I don't know what that means. Is that a good person, GD Flame? Thanks for the follow, by the way. So, negative 15 divided by 0.25 divided by the cosine of that ugly angle. Cool. And so we get p is equal to negative 156. Okay. Let's see. Oh, I am a good person. Oh, you weren't asking a question. Sorry, thank you. Sorry, my bad. Okay, here, let me... So let's just do this. 200... Oh, but now I need to... damn it. Okay, 65. I need to put everything back in radians. Damn it. Right here. No, I'm gonna do this in degrees. Because I don't want to figure out 65 degrees in radians right now. Okay. There we go. Does it make sense that phi is negative, though? Shouldn't phi be positive? I don't know. Maybe it's just in, like, whatever this format is. Oh, you know, I think I messed up here. Sorry. When doing this one, this should have been negative. Fuck. Okay. Sorry. I forgot that when you... Yeah, when you do the middle one... When you do the middle one for cross products, that one's negative. Okay, my bad. Yeah, 67.38 degrees. Okay, sorry. Yeah, let me fix that. It's okay. It's just a minus sign. What am I watching? You're watching physics, and I guess this is engineering, technically. Sorry, 67.38 degrees. Which, yeah, cosine of negative... It's the same thing, right? Or, no, wait, is it? Oh, shit. It is. Cosine of phi is equal to the same thing as cosine of minus phi. Okay, so this is going to be 156. Okay. So, wait. 200 sine of 65 times 156 cosine of 67 point, let's say 4. I'm gonna approximate. Cool. Plus 200 cosine of 65 degrees. Times 156 times the sine 67.4. I get 23,000 newtons. That's huge. Why? Wait, where did my 200? Oh, you know why? Oh, man. Because this should have been 0.2. Oh, God damn it. Sorry, 0.2. Oh, silly me. Okay, whatever. Yeah, sorry, divide by 1,000, right? Okay. Yeah, 23. 23 newtons? Yeah, I'm in millimeters. Okay, cool. Answer is 23 newtons. 23 newtons. And we did it. Nice. Awesome. Cool. Okay, cool. That was a cool question. I appreciate it, Muzin. That was a great one. You don't get bored or tired from doing so much mentally exhaustive study work? I mean, it's like going to the gym. Like, yeah, I get fucking tired at the gym, but that's how you get stronger. I definitely get tired from doing questions. And certainly when we start reaching the 3-hour mark, it starts showing because I'll make stupid mistakes. I just won't. Like my algebra won't carry over. Yeah, totally. Yeah, let me get the screenshot of this. Sorry. But yeah, but that's how you get stronger. You have to get exhausted. I had a good friend actually who would talk about in surfing. So I like to surf. I live in Los Angeles. Whenever you feel tired surfing and you want to quit and you want to go back in, stay out for another 5 minutes. Because doing that will push you to get a little bit stronger so that you can last another 5 minutes the next time you go out. Yes. There's no roids for learning. I'm all natty baby, dude. I don't even do creatine. I just eat chicken and lift weights. You need a bottle of beer right now? I drank a lot of bottles of beer last night, so I don't need any bottle of beer right now. Okay, cool. Nice. Good question, Misa. Jebediah, I wanted to get to you. Sorry, but I do have to go. I have to go teach another student in like 5 minutes. But if you come by tomorrow's stream, Jebediah, thank you again for your question. I see it. Let's see, where is it? It's this one right here, right? Yeah. I see your question. Let me do this. Can you come by my stream tomorrow? It's gonna be the same time tomorrow. I'll do it. Are you ex-military? No. Oh, definitely not military. Okay, cool. Can't wait for trigonometry question with drink. Okay, maybe on Monday. All right. I need to close that stream, so let's head out. All right. Thank you, everyone, for coming to Actual Education Office Hours today. Really appreciate all of the questions. You guys are awesome. The best. Our next stream is going to be tomorrow around the same time. If you ever want to figure out when it is. Yeah, thank you. You're more than welcome, La Palabaruja. But yeah, come on by. Our next stream will be tomorrow, 3 o'clock Pacific, 5 p.m. Central, 6 p.m. Eastern. So if you have any thing that's troubling you, math, science related, middle school, high school, early college, I will do my best to help you. And other people will watch and learn stuff. Cough, cough. 4 p.m. Mountain. Yeah, don't forget the Mountain Time people. All right, awesome. We got raided by Nerduino. Thanks again for the raid, Nerduino. He's an awesome streamer. I usually raid Nerduino during the week. I guess he was streaming before me. But we're gonna go. If you're watching us on Twitch, I'm gonna go raid another person. When I do my budget, I have more questions. Great. Yeah, awesome. Let's see. I guess no one really streams on the weekends. Ugh. Can I just look up like math? Or a category? Is math in there? I don't think math is. Who's streaming math right now? Yo, someone is. Well, they were testing. Damn it. Jaden, come by tomorrow too, and I'll help you out with more stuff. Here, maybe. Oh, you can filter by tags actually these days. That's cool. Math. Yeah, there we go. Intense studying. Yo, go raid this guy. Go say hi to this guy. I think this would be hilarious. Looks like he's studying. Love it. Okay, cool. All right. Enjoy the rest of the weekend. We will see you on Monday. Peace.